Okay, this is my video number 15. Number 15. Oh, it's not that clear, right? How can I make it this clearer? Okay, so I'll talk on the vector unit tangent. I'll give the definition of vector unit tangent, and also we will give definition for how to find curvature for the vector function, and of course with some example. Now let's look at the vector unit tangent first. Vector unit tangent. What is vector unit tangent? So if we consider the movement of the object, particle, right? And at certain point, let's say we have a position vector rt, right? Then vector unit tangent is given as tangent to that curve, tangent to it. So this is, we call it as a vector unit tangent. Okay, at particular points P. So if P here, then vector unit tangent is that. So it depends on, and of course we call it unit tangent because magnitude of T is 1. Okay, let's give a formal definition for this. So if Rt is a vector function, then the vector unit tangent we define as r prime t over magnitude of r prime t. So that's the vector unit tangent, and if we define r prime as a v velocity, then this is the velocity over magnitude of the velocity, where of course, as I mentioned here, that magnitude for t is 1. It is obvious. You take the magnitude both sides, then that gives you 1. Okay, as a simple example, find t for y equal to x squared at 0, 0 at the origin. Yeah, if you look at this unit tangent here, this is a vector, whereas the function given here is a vector function. Scalar function. So you have to be careful with that. So how to convert the scalar function to the vector function? So if you plot this or sketch this a little bit, just to see what it is. Yeah, y(x squared) is that. So what we want is vector unit tangent at 0, 0. So here. Okay. So from the given function y x squared, yeah, from y(x squared), if I can let x equal to t, then we have y equal to t squared. Therefore, from here, we can find what is the position vector of that point t, which is given as, we have x or t, and y is t squared, because this is the component of x, this is the component of y. Yeah, having done or having obtained y, then you can differentiate this. R prime, this is 1 over, 1 plus, 1 and 2t. And hence the magnitude of those, this is square root of 1 plus 4t squared. So therefore, the vector unit tangent is given as, at any point t, is given as r prime t over magnitude of r prime t, so which is 1 2t over square root 1 plus 4t squared. Now, as the required by the equation, we need to find the vector unit tangent at point 0, 0. So we just evaluate the t there. We evaluate t at point, this point, this is xy. This is xy, point xy. So you need to have t, so use that. Yes, since x equal to t, so when x 0, t is 0. So we have t 0. So we need at point t 0, that give you, so we have 1 0, and that one is 1, so we have 1 0. 1 0. So which means 1 in x direction and 0 in y direction. If you look at this, our sketching here, yeah, then vector unit tangent is given here, 1 and 0. That this is our t at point 0, 0. Okay, so that's the vector unit tangent. Now let's come back to the curvature. Definition: if t is a vector unit tangent, if t is vector unit tangent, can you read this? If t is a vector unit tangent to the curve R, okay, then the curvature is given as, then the curvature kappa is given as kappa equal to dt over ds. Okay, and we note that you can use a chain rule. Yeah, we note that dt this is equal to dt ds dt, and if you substitute this thing, so you can write this, of course, dt ds. From here you can write dt ds. This is what? dt that ds dt, using the chain rule. But what is ds dt? What is ds dt? Yeah. Also we have ds dt. Yeah. What is ds dt? ds dt is this, the magnitude of r prime t, we define as magnitude of r prime t. So therefore, Therefore, because if you given using this definition, t, the unit vector t is a function of t, but now this is I. So we need to change this into differentiation with respect to t. So yeah, instead of s, we need to change. So we use the chain rule to, and as well as the definition of ds dt. So from here we have kappa. This is dt ds, and dt ds is equal to this thing. So we have dt over ds dt. Okay, so what we have now is that this is the magnitude of dt dt, which is t prime, and ds dt is magnitude of r prime. So we have magnitude. I can write like this. Okay, so this is the how can we find the curvature for the vector function. Curvature for the, when you given, for example, given the vector unit tangent, you can find the curvature of the curve. Now let me give you an example. I just don't understand why it's not that clear as normal. Yeah. Okay, let me give you an example. Show that the curvature of a curve of a circle. So that the curvature of a circle of radius a is 1 over a. Radius a is 1 over a. Okay, for a circle, what is your x and y? For a circle, let's say radius a. Yeah, radius a. So this is your circle with radius a. So for this we have x is equal to what? A cos t, y equal to a sin t. Okay, so therefore you can write r, that circle, as r of t. Okay, we have component of x is a cos t, component of y is a sin t. Then if we differentiate this, we have r prime t, this is minus a sin t. For that we have a cos t, and if we take the magnitude of this, that gives us magnitude of r prime, that gives us a squared, sin squared, cos squared. You can factor out a, so plus sin squared, cos squared, that gives you 1, and square root of a squared, so that gives you a. Okay, so therefore the vector unit tangent is given as, we have r prime, which is that's vector unit tangent, and our A is given by that, so A cancel out with A, so vector unit tangent given just sine t cos t, yeah, because A cancel out with that, yeah. So therefore the curvature of t is given as magnitude of t prime of t over r prime of t, that give you, if you differentiate this, t prime, so you got cos squared negative cos, negative sine, and then we take the absolute of those, that give you 1, and magnitude of r prime that we have obtained earlier, this is A. So therefore we obtain the required result. And for the vector function, let's say we have a theorem. For the vector function r, the curvature is given as, we have r prime cross of cos function of t, r double prime of t over r prime t cube. Okay, proving this thing is not that difficult. Yeah, let me show that for the proof. So what we have, since we have t, we define as r prime over magnitude of r prime of cos function of t, and the definition of r prime, magnitude of r prime, we define this r ds dt. Okay, so from that we can have, from this relation you can have r prime, this is magnitude of r prime t. Okay, just from that, and then r prime is ds dt, so that we have ds dt t, and we can differentiate twice what we have now, r double prime, that give us, this is function of t, yeah, I just put this is function of t, so this means that d dt r prime, so our r prime is given as that, so d dt ds dt t. Okay, and what we have here, we use the product rule, differentiate that, we have t2s dt squared, we fix t plus ds dt, we differentiate t. So if we find what is r prime cross r double prime, put there, what will happen. So we have r prime cross r double prime, that give us, okay, r prime, we have ds dt t, so we have ds dt t cross, we have r prime. So this, all right. So cross t2s dt squared t plus ds dt t. And note that of course t times t, that gives you 0. Okay, t times t, that gives you 0 because they are parallel vector, because it's t. Alright, so what left, if you look at here, we have t cross t, so which is 0. So what left is just this term here and that term. So what we have now is that ds dt squared t times t prime. And if we take the magnitude of r prime r double prime, therefore we have magnitude of r prime r double prime. This part here is always positive because we have squared there. So we have ds dt squared. For this part we have magnitude of t cross t prime. Of course, from here you can use definition here. You can use the definition that this is t cross t prime. This is, by definition, we have magnitude of t prime sine theta. And the angle between t and t prime, t and t prime, always perpendicular. Which means theta is pi over 2. So theta pi over 2, you got 1. Magnitude of t, that 1. So this is 1. This is 1. Because theta is pi over 2. The angle between theta is the angle between t and t prime, and they are perpendicular. So that's the thing. So what left is we have, this is ds dt squared t prime. Okay. Now we can write this t prime, put it left side, just rearrange this. So we have t prime, this is r times r double prime over those things, right? ds dt squared. And ds dt is given here. This is ds dt. Okay, so therefore we can write this r prime times r double prime, and this is, we have r prime squared. So therefore, by definition of curvature, which is t prime over r prime, magnitude of t prime over magnitude of r prime, that give you t prime is this. So we have r prime times r double prime. So here we have 2, here we have 1, so we have r prime cube. So this is the required proof that we want. Okay, so let me give you an example. So let's say r is given as, we have t squared and t cubed. Find kappa at point 0, 0, 0. Now please note that at this, up to this point, we have many definition of curvature. Yeah, from the very beginning, that's the rate of change between s and theta, and then we proceed up to now that involve tangent, unit tangent as well as vector unit tangent. So we have many definitions from that. Now for the given vector function that, so we need to find kappa. So the definition of kappa, let me write those things. Kappa is t prime over r prime. Okay, so we need to find what is r prime. We need to find what is t prime. So first of all, of course, we need to find r prime in order to find t. Okay, so and we know that t, this is r prime over r. Okay, so bear this in mind. So we use those things. Now from there we need to find what is r prime. We need to find what is r prime. Correct? So r prime is, we have 1 plus 2t plus 3t squared. Okay, from there we have r double prime. This is 0 to 6t. Alright. Okay. And also from the last not last lecture, but last page, we have t prime, magnitude of t prime. This is given as we have r prime cross r double prime over r prime squared. Okay, so from there we need r prime times r double prime. So r prime times r double prime, you can find this easily. Yeah, and we take the magnitude. If you do this, what you got, how to do this, this is I, J, K. For r prime you have 1, 2t, 3t squared, 0 to 6t. Right, that will give you, for I we have 2t, so 12t squared minus 6t squared, so you have 6t squared. For j we have that 0, so minus 60, and for k we have 2, right? Okay, so we have 2. Am I correct here? Seems okay. Alright. Then we take the magnitude of r prime times r double prime. So that give you, we have 36 t4 plus 36 t squared plus 4. Okay, of course you can factor out 4, that gives you 2. We have 9 t4 plus 9 t squared plus 1. So therefore kappa, we use that definition. We have t prime is given there, t prime over r prime. Where is it? I think we have okay, that's correct. Okay, so we have this is kappa is t prime over r prime, magnitude, and this is equal to r double prime times r double prime, r prime r double prime over r prime cube. Okay, just substitute everything there. So we have magnitude of r primes r double prime given by that. So we have 2 square root 9 t4 plus 9 t2 plus 1 over magnitude of r. You can find magnitude of r. This is square root of 1 plus 4 t squared plus 94. Alright, and to the power of 3. Forget that. Then you can rewrite this, arrange accordingly. So we have 2. I can write this like 1 plus 9t squared plus 94 to the half divide by, so we have 1 plus 4t squared plus 94, this is power 3, so 3 over 2. So this is the solution, but we need to evaluate at point 0, 0, so therefore k at point 0, 0, you can find this k0, this is t, 2. Okay, if we consider a, let's say y equal to fx, if you consider y equal to fx, then we write r and r as x of x, yeah, this is x, this is y. So what you can find that later on, this kappa, if you do this, you will have kappa of x is just f double prime x over 1 plus 1 prime x squared 3 over 2. So this formula we have seen when I first introduced you the quadrature in the for the real value function. Of course, you can have this taking y equal to fx, and then from there you can find what r. Then you can have r prime, you can have r double prime. You substitute into those formula, and then you got k as given like that. Okay. So let's continue. I have discussed the vector unit tangent. I have discussed the curvature in for the vector function. Now let's go a little bit further. I would like to give a definition for the vector unit normal. So we have vector unit tangent. Now let's look at the vector unit normal. Vector unit normal. So we define the vector unit normal as n t, this is t prime of t over t prime. That's vector unit normal. Okay, so note that the vector unit normal n, this is, we have t prime. I can write t prime as a, because this dt dt, so we can write this as a dt ds over t prime. That's a magnitude of dt ds. Okay, then you can write this. You can write this, since we have kappa we define as dt ds, magnitude dt ds. So what we have from there, this is equal to inverse of kappa dt ds. Okay, just a note there. And another definition, we have a binormal vector. Another definition, the binormal vector denote as B. We define as B is T of T times N of T, and B binormal perpendicular to T and also perpendicular to N. Of course, T and N are perpendicular, and the magnitude of B, this is 1. So if you can describe or figurize the position of T, B and N, yeah, consider the curve. Let's say that's our curve. From the any position vector T R there, let's say this is our position vector RT. Okay, then vector unit tangent, we have tangent to that at point P, say, so this is vector unit tangent. Then vector unit normal, so we have vector unit normal is given as that. So this is your N. Then from that definition, you can find what B is. You can use the that one, right hand rule. So we have T N, difficult. Okay, T N and goes up. T N, that's it. So we have this is in which direction? T. Okay. So this is your B. Okay, where B is B perpendicular to N, B perpendicular to T, okay, and N also perpendicular to T. So this is the at any point T, B and N, the position of T, B and N is given as that. Okay, so let's say example. To find B, of course, you take a little bit longer, not difficult. Okay, let's say example. Given R T as cos T, sin T, and T, find N and B. Of course, in order to find N, we need T. To find N, we need T, T prime over T prime, and B, and T itself is given as R prime over magnitude of R prime, and B is T by N. Okay, so based on that, we need to find R prime. So R prime is, that is negative sine t cos t and 1, then you can find what is t. So from there we have t is given as r prime over magnitude of r prime. Magnitude of r prime is sec2, right? So we have 1 over sec2 minus sine t cos t and 1. So if we differentiate t, in order to find n, we need to differentiate t. So t prime, that give you, we have 1 over sec2. This will give you negative cos t, negative sine t, and 0. And hence we can find the magnitude of t prime. This is, that give you 1, just 1 over sec2. So therefore we can find n, which is t prime over magnitude of t prime. So we have t prime is given here. So we end up with that's half 1 over sec2. We have 1 over sec2, so that cancel out. So what left is just negative cos t, negative sine t, and 0. So this is the unit normal vector. And for B, you need to perform the cross product between t and m, t and n. That give you, our t is where t? We have 1 over sec2 here. So we can put the t is all those things. So we have I, j, k. For t, we have 1 over negative 1 over sec2 sine t. For that, 1 over 2 cos t. And then that we have 1 over sec2. And for n, is given there, we have negative cos t, negative sine t, and 0. So this is not difficult for you. Again, to just perform the cross product to find I. We have 0, so we have 1 over sec2 sine t. For that we have that one is 0, then you have 1 over 2 cos t. For that we have the sine squared, cos squared, 1 over sec t. So that gives you 1 over sec2. First is sine t, then you have negative cos t, and then you have 1. This is your binormal vector. Now, if the function given on t, then it might be a little bit I would say not difficult to give, because it just involve square root, and if you're given that kind of function. Okay, for example, let me consider this. Given r, just 2t plus 3 t squared minus 1, just 2 dimension, yeah, just that. Okay, so find n and show that t and n at all time. Show that t and n always orthogonal along the along the arc. Okay, so I think you have arc here, so we can find I'm not going to solve everything here. And of course you can find b as well if you want. Let me put extra there. Find b. Okay, so solution we find if you differentiate those r prime, so that give you 2 to t. Magnitude of those, that give you 4 plus 4t squared. Yeah. 4 plus 4t squared. Of course I can write this as a 2 1 plus t squared. And therefore our t is r over magnitude of r, that give you 2 to 2. You can cancel out, so what left is 1 t over 1 plus t squared. Okay, so in order to find n and b, of course you need to differentiate those things. Yeah, dt dt. Okay, you do this. That's not difficult. You can do, basically you can do this. It's not very difficult. So just I give you the result. So this give you minus t over 1 plus t squared 3 over 2. Please check, yeah? Please check. And then next we have 1 over 1 plus t squared 3 over 2. And then next you find what is the magnitude of dt dt. Yeah, magnitude of those. That give you, have 1 over t squared plus 1. So therefore your n is given as negative t over 1 plus t squared half and 1 over 1 plus t squared half. And to show orthogon, n always orthogonal to t. So what we need to show that t dot n. Yeah, perform this t dot n. You can proceed this, that will give you 0. Then you can come up with the conclusion that therefore t always perpendicular orthogon to n. Okay. Now I think with that example and the definition of binomial, yeah, I have given a definition for the tangent, unit vector unit tangent, unit vector unit normal, as well as binomial. I've given some example related to all those definitions, and also the properties of or the interrelation between t, n, and b, which is they are perpendicular to each other. So I think I stop here for this video. Alright, and then we meet again in other video. Okay, bye bye.